Hi everyone, so today I'm going to be talking to you about factoring trinomials, okay? And let's just recall from previous section that a trinomial, and I see the word tri in there, has three terms, and tri means three, okay? It has three terms, kind of like this guy, x squared minus 3x minus 10. That's a trinomial. That's actually a very specific type of trinomial that we would like to call, that we call quadratic form, okay? So these are the ones that we're interested in. A trinomial that is written in the form ax squared plus bx plus c. Those are the ones we're going to be talking about for this factoring of trinomials. Again, we call them quadratic form. Each part of the trinomial has a certain name. So the variable raised to the 2 power, we call that the quadratic term. I want you to get used to saying quadratic. So anytime you look at an expression in which the highest exponent is a 2, it's quadratic. Now, this middle term, this negative 3x, we call the linear term. Its exponent is a 1. So all variables raised to the exponent of 1 are called the linear terms. Now, negative 10, we don't see a variable, there's one hidden, but it's just a plain old number, and we call that a constant term, meaning it's unchanging, it remains constant. Okay, so that is quadratic form, and that is actually what we're going to be factoring. Okay, so what is factoring? Factoring is when we take a trinomial and we write it as the product of two binomials. We call it factoring. So what do I mean by product? Product means multiply. So if I take two binomials, maybe something like x minus 2 and x plus 4, that's factored form. This is a factor and this is a factor of the trinomial we just factored, okay? All right, so basically what we're trying to do when we factor is to undo it. So we're trying to turn x squared minus 3x minus 10 into its factors. So x minus 5 is a factor of x squared minus 3x minus 10, and x plus 2 is a factor. So we really need to know how to do this because it's going to help us solve equations like this one, x squared minus 3x minus 10 equals 0. We're going to do that later. So for now, we're just looking at expressions and we're just looking at factoring them into their two factors or more. All right, so in order for us to be good at this the skill of factoring, we've got to master this one skill, okay? So we need to be able to do something like this. Find two numbers that follow the rule, okay? So I'm looking for two numbers whose sum is 11, so that means they add to 11, and whose product, which means they multiply, their product is 24. Now, you always want to start with the product because we can list the factors. So if I'm looking for the factors of 24, I start in order. I go 1 and 24, 2 and 12, 3 and 8, those are all factors, and then 4 and 6. Those are the factors, the things that multiply to give me 24. Okay, now which one of those add to 11? Well, 8 and 3. So two numbers that follow the rule would be 8 and 3. All right, let's make it a little bit harder. We want to find two numbers who add to 3 and multiply to 40, or negative 40. So, all right, the first thing I do is I look at my factors. Now, I disregard the negative for a second. So I just look at the factors. So I'm going to do 1 and 40, and again, I follow an order. 1 and 40, 2 and 20, 3 doesn't go into 40, so 4 and 10, and 5 and 8. Okay, now in order for them to be negative, multiply to a negative, that means one has to be negative, especially if I want them to add to a positive 3. Well, 1 and 40 are too far away to add to a positive 3. So are 2 and 20. And 4 and 10 will never add to a positive 3, but 8 and 5 could. But in order for them to multiply to negative 40 and add to 3, well, what would have to be true? Well, first of all, 8 and 5, one of them has to be negative. And if they're going to add to 3, that means that the 5 has to be the negative one. So I'm going to make the 5 negative, the 8's going to be positive. That way, when we multiply them, 8 times negative 5 would give me negative 40. So my factors are 8 and negative 5. All right, let's try another one. We want now to multiply to negative 18, but add to a negative 7. Okay, so we go through my factors, disregard the sign for a second. 1 and 18, 2 and 9, 3 and 6. Okay, I notice that 2 and 9 are 7 away from each other. I want them to multiply to a negative 18, but add to a negative 7, which would mean the larger term has to be negative. So 2 times negative 9 gives me negative 18, and then 2 plus negative 9 gives me negative 7. So my factors are 2 and negative 9. All right, last one. I want numbers that add to negative 10 and multiply to 24. Okay, so I write down my factors. 1 and 24, 2 and 12, 3 and 8, 6 and 4. Okay, so 6 and 4, I notice, are going to add to 10, but I need them to add to a negative 10, but I need them to multiply to a positive 24. If they're going to add to a negative and multiply to a positive, that means that both of them have to be negative. So negative 6 and negative 4, those do add to negative 10 and multiply to negative 24. All right. All right, so hopefully that wasn't too bad. Now we're going to put this to work, and we're going to use our technique to factor. So we look at our first trinomial, x squared plus 6x plus 5. Now, we still go through our process. Our first step is to look for a greatest common factor between all the terms. There is no GCF besides 1, so we're past that step. Then we look for 2 terms. Well, this is 3, so it's not going to be dots, because that's the difference of 2 squares. If it's 3 terms, we always want to look for a perfect square trinomial. 5 is not a perfect square, so it's not a PST. So then we would go on to the 4th step, which is trinomial factoring. All right, so that skill you just learned, we have to put to work. We're looking for the things that add to 6 and multiply to 5. When we factor it, our result is going to be 2 binomials, and when our coefficient in front of x squared is 1, then we know our first terms are going to be x and x. So for now, that's all you have to worry about. X times x gives me x squared. All right, so the numbers that are factors of 5 are 1 and 5. And in this case, 1 and 5 also add to a positive 6. So it would be x plus 1, x plus 5. All right, now, if I wanted to verify that, if this is undoing the trinomial, then if I FOIL it or multiply it, then I'll get back to x squared plus 6x plus 5. So let's test that out. So x times x gives me x squared. We're just checking now. X times 5, that's my outers, that's 5x. Then I go to my inners, 1 times x, which is x, and then 1 times 5, which is positive 5. I combine the like terms, and I get x squared plus 6x plus 5. It checks out, so my answer, x plus 1 times x plus 5. Done, factored. All right, we go on to the next one. We go through our process. Is there a GCF? Nope. 2 terms? Nope. 3 terms. Is it a PST? Perfect square, positive perfect square, double the product of their roots. So yes, it is a PST. So that's when I use my factor pattern. My factor pattern, the result of a perfect square trinomial is the square of a binomial. We take the square root of the first term, the square root of the last term, and the sine of the middle term. So just don't ever forget that. We always want to go to perfect square trinomials first if we can. All right, we're going to try another one. X squared minus 7x plus 12. So I'm looking for things that add to negative 7 and multiply to 12. Okay, so we make our 2 binomials. We look carefully. There's a coefficient of 1 in front, so that's going to give me x and x. And my factors of 12. 1 and 12, 2 and 6, 3 and 4. Okay, so I see that 3 and 4, they do multiply to a positive 12. But in order for them to add to negative 7, these would both need to be negative. So x minus 3, x minus 4. And now I'm going to FOIL to check. Okay, so x times x gives me x squared. X times 4 gives me negative 4x. X times negative 3 gives me negative 3x. And then negative 3 times negative 4 gives me positive 12. So x squared minus 7x plus 12. I FOILed, I checked it, so that is my answer. All right, so hopefully you're noticing that foiling can be really, really tedious to check. even though you could do it, okay? So I'm going to show you a little method that I like called the smiley face check. You know, Coach Fred always likes to smile, right? So when I look at x squared minus 2x minus 63 and I go through my process, I'm still going to look for the numbers that add to -2 and multiply to -63. But, and I write down my factors, so 1 and 63, 3 and 21, and then 9 and 7. So I can see that these are just too big. So 9 and 7 are my factors, right? But I need them to add to a -2. So that would mean that the larger term has to be negative. So -9 times +7 does give me a -63 and a -2. But one way I always like to check myself is I like to look at the O and the I of FOIL, because I know that x times x gives me x squared, so I don't have to worry about the first. And I know that -9 times 7 gives me -63, which is the last. It's the O and I always want to make sure I've done right. So I actually connect the inner terms and the outer terms. So it's almost like 2 eyes, a nose, and a mouth. Okay? And so I connect them. And then I multiply those numbers and I write it just below it. So -9 times x is -x. +7 times x is 7x. I add these numbers together and I get -2x, which is what I'm looking for my middle term. I've checked it, so I'm done. Okay. All right, guys, I know that was a lot, so I'm going to ask you to just try. I want you to try the next two. That's it. Just try them. Make an attempt. You know you're looking to make it the product of two binomials. So try and put together what we just did, and then we're going to be practicing for the next couple of days in class. Thanks for your patience tonight. Have a great night.